All right, welcome. So, if you're getting into C programming, you know there's one topic that can feel like a final boss: pointers. But honestly, don't worry. Today, we're going to pull back the curtain on one of C's most powerful features and get you totally ready for any exam question that gets thrown your way.
Okay, so let's just dive right in. Yeah, pointers have this reputation for being super confusing, right? But what if I told you it all boils down to one super simple idea you already get? We're going to break this whole thing down with a single concept you already understand.
I want you to just picture your computer's memory, its RAM, as this really, really long street, just lined with mailboxes. And every time you create a variable, you're basically just getting one of those mailboxes to stick something inside.
And here's the thing. Every single one of those mailboxes has its own unique street number. That's its memory address. It's the specific location that tells the computer exactly where to find that variable. You can actually ask the computer, hey, what's the address for this? And it'll spit out this long, kind of scary-looking hexadecimal number, something like what you're seeing here.
This slide really just breaks it all down to two essential tools. Let's call them keys. Over on the left, you've got the ampersand, the and symbol. Think of this as your address of key. You use it on a variable, and boom, it tells you the mailbox number. And on the right, you've got the asterisk, the star. This is your dereference key. You give it an address, and it's like using the key to unlock the mailbox and see what's inside.
And that brings us right to the pointer itself. So what is a pointer? Well, it's just another variable. But here's the twist. Instead of holding a regular value like the number 10 or a letter, its only job, its entire purpose, is to hold the memory address of another variable. It's kind of like a little sticky note where you've jotted down a friend's address so you can find their house later.
Okay, theory is great, but let's see how this stuff actually works. We're going to run through what I'm calling the exam gauntlet. Just a few quick questions you'd totally see on a test. This will really help lock it all in.
All right, first one up. Let's break down this code. First line, int x equals 10. Super simple. We've got a variable x with the value 10. Next line, int p equals end x. Okay, so here we're creating an integer pointer. We're calling it p, and we're setting it equal to the address of x, using that ampersand key. So p is now pointing right at x. The final line asks us to print star p. So, what do you think is going to pop out on the screen?
And the answer is 10. Of course it is. And here's why. Because we used that asterisk, that star key, we were telling the program, hey, don't just print the address that's stored inside p. I want you to go to that address, unlock that mailbox, and tell me what value you find. And well, the value in x's mailbox is 10.
Okay, let's do another one. The first two lines, exactly the same. X is 10, and our pointer p has the address of x. But check out that third line. Star p equals 8. Whoa, now we're using our dereference key not just to look at the value, but to assign a new one. So after this code runs, what do you think the value of x is now?
And this right here, this is where you see the real power of pointers. The value of x is now 8. Think about it. When we said star p equals 8, we told the computer, go to the address that p is holding, which we know is x's address, and change whatever's in that mailbox to the number 8. We literally changed x without ever calling it by name.
Okay, this one looks a little scary, I know, but the logic is exactly the same. You just follow the trail of addresses. So, first line, int x equals 4. Got it? Next, int p equals and x. So p is pointing to x. Now look at this new one, int double p equals and p. See the two asterisks? This is a pointer to a pointer. All it means is that p is a variable that stores the address of p. So, when the code asks to print double p, what value are we going to get at the end of the line?
It's got to be 4. Just follow the chain. The first asterisk on pp takes you to what pp is pointing to, which is p. Then the second asterisk takes you to what p is pointing to, which is x. It's just a chain of addresses that leads you right back to the original value. You just follow the breadcrumbs.
So yeah, following that chain of addresses is kind of neat, but you might be thinking, so what? Why is this such a huge deal in C programming? Well, the real power, the reason pointers are so fundamental, is what they let you do with functions. They let a function reach outside of itself and change variables that belong to a totally different part of your program.
This is absolutely crucial to understand. Normally, you're just sending a copy of your variable to a function, but with pointers, you're sending its home address. So let's walk through this. You start with a variable, x, in your main function. Then you call another function, but instead of passing the value of x, you pass the address of x. Inside that function, a pointer is waiting to catch that address. And now, that function has the key. It can use the asterisk to reach all the way back to the original x and change its value directly.
Okay, let's wrap this up. I want to go over the most important takeaways, the stuff you absolutely need for any test, and then we'll touch on a couple of common mistakes so you can write safer code. Think of this slide as your go-to cheat sheet. If you can explain these 4 things, you've totally got the fundamentals down. 1. A pointer is just a variable that holds a memory address. 2. The ampersand and gets you that address. 3. The asterisk star gets you the value at that address. And 4. This whole system is what lets functions directly change the variables you give them. That's it. That's the core.
Now, as they say, with great power comes great responsibility. The number one biggest mistake people make is trying to use a pointer before they've given it a valid address to point to. That's like having a key, but no idea which mailbox it goes to. If you try to use it, you're just going to cause chaos, or more likely, your program is just going to crash. So rule number 1, always make sure your pointers are pointing to a valid spot in memory before you try to use them.
And that really leaves us with one final thought to chew on. Pointers give you this incredible, direct control over your computer's memory. You basically have the map and all the keys. So, as you start writing bigger and more complex programs, the real question becomes, how do you use this power effectively, while also making sure you're protecting that information from being accidentally changed or corrupted? And that, right there, that's the next step in becoming a great C programmer.